Yes, you do make us happy. You are the sunshine of our lives. You are going to have a fun time with the math today. You won't believe how happy it makes you. You are welcome to the Johnson Kendro video hour.
But it's not an hour.
That's right. But you will be happy to know that we are going to talk about U-shaped graphs. They are also known as parabolas or quadratics. All right, if you can look on the middle of the page, it says standard form, y equals ax squared plus bx plus c. The only thing it can't have is a being 0, because then it wouldn't be a quadratic anymore. It'd be a regular line. All right, features of parabolas. All right, see that beautiful picture there? It's a curve. It's a U shape. All right, the first thing is the vertex. Vertex is your high or low point. In our case right here, it's at 0, 0. It's right there. The next thing is the axis of symmetry. The x value is always our axis. Our x value is 0, so we say x equals 0 is our axis of symmetry. And you can actually draw it in there and it makes a symmetrical line down the middle. So if you folded that picture in half, it would fold right on that dotted line. They also want to know about the maximum and minimum values. What that really is telling you is what is the y value of the vertex. So in our case, the minimum is going to be y equals 0. It's minimum because it's at the bottom. It's the lowest. And you probably need to write minimum in there so we know that you know it's at the bottom.
Why isn't it a maximum? That thing points up.
Well, but the point itself at the bottom is the minimum. It's the vertex is where the minimum or maximum is.
I see.
So it's the lowest point of the U-shaped curve. All right, the other thing is the range. The range has to do with your y value. And basically it's how high up or how low does this go. It always starts at either y is greater than or equal to or y is less than or equal to. All our y values are above the x-axis. So in this case, it's y is greater than or equal to 0. All right, next picture over here. So this one is upside down. It's a sad face. But remember, you are our sunshine, so it's happy faces everywhere. All right, our vertex, once again, is 0, 0. Okay, same spot, hasn't changed. Axis of symmetry, still going down the middle, and it's always the x value here, so x equals 0. The maximum or minimum is going to be the y value. In our case, again, it's y equals 0. This time, though, it's a maximum because it's at the highest point. And then we have the range. Our y value this time, all our y's are below the x-axis, so we say less than or equal to 0. All right, finding the vertex. Put it in standard form. Standard form is a ax squared plus bx plus c, and then you want to identify a, b, and c in there. To find the x-coordinate of the vertex, all you have to do is this tiny little formula. It's really cute. You take the b value.
Like us?
Yes, very much like us. Cute. Kendro and Johnson are cute. So, we're going to try that, and then to find the y-coordinate, you put the x back in, and then you write it as a point. So let's do an example. All right, here we go. So first thing I'm going to do is put it in standard form, which it already is. Then I'm going to write that right above it, ax squared plus bx plus c. So now I can see exactly what a is. I have a 1 in front here, so a is 1. The b turns out to be the 2 right here, and then the c is 1. All right, the next thing we do is to find the x-coordinate. X is our little formula, negative b over 2a. Put in negative b, that'll be negative 2, and then 2 times a, so I get negative 1. Now right away, I'm going to put that as part of an ordered pair to remind myself I need to find the y part too. So what we're going to do next, plug it back in.
Where do you plug it?
I put it right back into this equation that I have because it's got the y and the x. So y is equal to x squared.
Ooh, I like your parentheses.
Thanks. I always do that because then I don't forget my negative sign has to be squared also. And 2 times negative 1, and then plus 1. Work it out. Negative 1 squared is 1. Negative 1 times 2 is negative 2. And 1. Put all that together, and I get nothing. All that for nothing. So negative 1, 0 is the vertex. And one more example here. We're getting there. Delete. There we go. Finally figured it out. All right, same thing. We have to find the A, B, and C. So my A is negative 3, B is negative 8, and C is 8. Don't forget this negative signs go with the A, B, and C. Next, to find the x-coordinate, we do negative b over 2a. Negative b would be negative negative 8. So that's just 8. And then 2 times negative 3.
Uh-oh, we're going to get fractions.
Uh-oh, fractions are on the horizon here. We got 8 and a negative 6. I'm going to reduce that 4, negative 3. Now that's the x-coordinate. Let's put that back in. Now we have to be extra careful here when we put those in. So negative 3, and then the
Where are you putting it again?
I'm putting it right back in the only equation that I have.
Okay.
All right, so negative 3 times 4, negative 3 squared minus 8 for negative 3 plus 8. All right, you got to do your exponents first. So 4/3 squared, the negative disappears because it gets squared, and I get 16 ninths.
Oh, you just square both.
Yeah, square both, top and bottom. And then this one, pretend it's 8 over 1. You can multiply straight across. Now I have 2 negative signs. 2 negative signs right here and here. There we go. Those make positive, so I'm going to keep that positive. 8 times 4 is 32. 1 times 3 is 3. And then I have the 8 on the end. All right, a little more room here. Okay, I have a 3 over 1 and a 9. You can do some reducing before you start. Make that a 1 and that a 3, and that might help a little bit. So negative 1 times 16, and then the 3 underneath. Then I have 32/3. I'm seeing thirds on the bottom, so I'm going to change this to thirds by multiplying it there. So I get 24/3. Then I put those together. Let's see. I have negative 16 plus 32 plus 24. Let's see, how much is that? That's 16 plus 24 is 40/3. Wow, a lot of work there because of the fraction stuff. Take your time on these because the positives and negatives can mess you up, and so can the fractions. All right, Ms. Johnson, take her away.
All right, we're going to start doing our graphing. So we practice finding the vertex because that's a necessary step when we start graphing. So the nice part about the steps we've been using for the absolute values and other things is they apply here. All that's going to change is we have a different shape. So we always want to make sure we have standard form. Most of the time that's done for you already. The next step says to find the vertex because that's going to tell us where our graph has shifted. We're going to use what Mrs. Kendall was teaching us, negative b over 2a.
That cute little formula.
That's right. Here's my a, here's my b, here's my c. So plugging them in, opposite of b or negative b will be negative 4. Over 2 times 2, we will get a negative 1. Then we have to plug it back in to find our y value. Lots of negative 1s. All right, square the negative 1 first. That's going to go to positive 1, but then we're going to have to multiply it by 2, and we will get positive 2. Next, I have 4 times negative 1. That's negative 4. And then I'm going to subtract 1 more. Add them all together. I end up with a negative 3. So my vertex is negative 1, negative 3. That's going to be my shift. That means that from the origin it moves left 1 and down 3. Okay, that's our dot, but we need the U shape. So we've done this and this. Now we're down to creating the shape chart. The shape, just like with the absolute values, just deals with the beginning part of the graph. So y equals 2x squared. And you can choose wisely.
Choose wisely, grasshopper.
And pick easy things. Okay? And if we ever have fractions, we'll pick multiples of the denominator. Plug these into my shape chart. We'll get 0, 2, and 8 when we do that. Now, let's talk about what that shape would look like. That's going from the origin. 0, 0, 1, 2, 1, 2.
1, 2, buckle your shoe.
And 2, 8 would look like this. And we know that it's going to be symmetrical, just like our V's were, so we can reflect on the other side. But remember, that's not our final answer, because our graph is shifting according to the new vertex. So all those points need to move. Instead of the vertex being at 0, 0, it needs to move to -1, -3, so it will be down there. So I'm going to shift each of those dots and recreate my shape. They're all going down 1, or left 1 and down 3. And when you connect, try your best. These are not V's. These are U.
You are our sunshine.
That's right. All right. In your book problems that you do, they're going to have you do the graphing, and then they want you to identify those features of the graph. Mrs. Kendall talked about those. The vertex, we found that already. It's at -1, -3. Remember, the axis of symmetry goes right down the middle, and it's going to have the same x value as the vertex. You need to know if this is a minimum or a maximum. This is a minimum because it has a lowest point, and that's the y value. So -3. The last thing is the range. Think about what's going on here. All the y values are above that, okay, and that y value is -3. So y is greater than or equal to -3 is the range. All right?
All right.
We've got one final hint for you. You occasionally will see equations that look like this. And this is a little different than standard form because something's missing. What's missing, Mrs. Kendro?
Well, I'm missing my students right now because they're not with us. But I don't see a regular x term in the middle.
Yes, what that means is really that we have 0 x's, okay? So there is no b, it's 0. So that means when you go to do your formula, opposite of b over 2a, you're going to get a 0 over whatever. What's 0 over whatever?
0.
0, that's right. And then when you take that number and you plug it back in, think about it. We're going to do 2 times 0 squared, and then we're going to subtract 6. 0 squared is 0, times 2, still 0, that's 0, and we'll get -6. So the vertex is at 0, -6. Do you notice where that -6 might have come from?
Oh my goodness, it's that last number.
That's right. So anytime your b is 0, automatically your vertex is going to appear at 0, whatever the c value is.
Oh, very cool.
And that can be a shortcut for us.
Yeah, it is. All right, there's one more thing I need to ox you. Are you going to have a good day tomorrow? Yes! See you tomorrow.